Okay, we're going to find the highest common factor of 45 and 72. I'm just going to write that in shorthand actually. Highest common factor of 45 and 72. Okay, highest. Actually, now let's go with factor. So we're looking for a factor of 45 and 72 that is common to both. Now there are lots of factors that are common to both 45 and 72, and we want the highest common factor. So what we could do is we could write a list of the factors of 45, and we could list the factors of 72. 72, 1 times 72, 2 times 36, etc. And then we would find the factor that is common to both 72 and 45, and then choose, and we're going to get lots. For example, actually let's just write a few more. 45 is 1, that's 45, 2 doesn't go, but 3 does, 3 times 15. So we can see, for example, that 1 is a common factor of 45 and 72. But we want the factor somewhere in here which is the highest common factor. And the process we're going to use is prime factorisation. So let's find the prime factorisation of 45 and 72. So 45. Now the smallest prime number that goes into 45 is 3. How many times? 15. This is the smallest prime number that goes into 15. 3. How many times? 5. 3 times 3 is 9, times 5 is 45. We have written 45 as the product of its prime factors. Let's do the same with 72. This is an even number, so 2 is the smallest prime number, which is a factor of 72, and 2 times 36 is 72. What's the smallest prime number that goes into 36? Again, it's even, so 2 times 36 is 2 times 18. Same again, 2 times 9. 9 isn't even, so the smallest prime number that goes into 9 is 3, and in fact 3 times 3 is 9. They're both prime numbers, so that's the end of the process. Now I'm going to write 72 directly underneath the 45, and that was 2 times 2 times 2 times 3 times 3. So 72 can be written as the product, multiplication there, of its prime factors. Now we're looking for the highest common factor of 45 and 72. So we look for the common prime factors. Now if you notice, 2 isn't one of the prime factors of 45, so we can ignore those, but 3 is. So we're actually going to choose that 3 there, 3 times, and in fact that 3 is also common. It's common to the 45 and the 72. Nothing else is. And so we have found that the highest common factor of 45 and 72 is in fact 9. That's okay. I think we should do another one. Let's find, I'm going to use shorthand, the highest common factor of 90 and 420. Now choose 420 because we could, and 90, we could list all of the factors of 90 and 420, but it would take a while. So here, the process of using prime factorisation is beneficial to us. Okay, 90. Smallest prime number that goes into 90, well that's an even, 90 is even, so it's going to be 2. 2 times 45. 3 times 15, and then 3 times 5, so we can write 90 here. The product of its prime factors is 2 times 3 times 3 times 5. Okay, what about 420? Well, that's an even number, and so therefore 2 is the smallest prime number that goes into it, and 2 times 210 is 420. Again, it's even, so the smallest prime number that goes into 210 is 2, and it goes in 105 times. Okay, now 105 isn't even, but we notice that 1 plus 0 plus 5 equals 6, which is divisible by 3, so that means 105 is divisible by 3. So let's divide 105 by 3, which is in fact 35, and the prime factorization of 35 is 5 times 7, so 420 can be written as the product of the prime numbers 2 times 2 times 3 times 5 times 7. We want the highest common factor of 90 and 420. Common is the key word. We're looking for the common prime factors. Can we see that 2 is common? Why don't we have that 3 there, that's common, and that 5 is common. And so 2 times 5 is 10 times 3 is 30. 30 is the highest common factor of 90 and 420.